hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode weekly contest 435 problem number D, and the problem is maximum difference between even and odd frequency 2, and this is a hard level problem. And now let's discuss their problem statement. Then we have to further dry run their example test cases and their coding implementation part. So now we have to given a string s and integer k, and your task is to find the maximum difference between frequency of two characters. The character is frequency of a minus frequency of b in a substring of subs of s, such that we have given 3 points, and then we have to return maximum difference. And this is our node. And now let's discuss their problem statement. So in this problem we have to given a string s. This string s is consist the digit, and this string consists digits. Okay, and now an integer of k we have to given here, and our goal is to find the maximum difference between the frequencies of two, frequency of a minus frequency of b, and in this frequency we have to find their contiguous subsequence of s. Okay, and these are our 3 points. The first point we have given here is a substring has a length at least k, and the second one is we have to given one character of one character of a. This this a is the substring must appear on odd numbers of times, like this a is substring must appear an odd number of times. And the same thing for b, the substring must appear their frequency of subs with even number, here even number. Okay, and now our task is to find the maximum value of frequency of a minus frequency of b, and this is we have to find. And if no valid substring satisfy the condition, these are our conditions, and the condition is not satisfied, then we have to directly return -1. So now let's discuss this one. Like we have to given string s and k, and find the maximum difference between their frequencies, and frequency of a minus frequency of b, and at least the substring must the size of at least k, and the a is frequency is odd frequency, b is frequency is even frequency, and then important notes are substring can contain more than 2 distinct character. Distinct character mean like here is another character, here is another, here is another, like so on, you can say. And a substring must has a contiguous subsequence or sequence of characters we have given here. And this is our example test case. Okay, so this is this one 1 2 1 2 2 3 3. Okay, and now we have their frequencies we have to calculate here, and the frequency of 1 is 1, this is odd, and the same thing for frequency of 2 is 2, and this is even, and the frequency of 3 is also be even, 2 times this 3 is occur, and this is even also. And then we have to find their difference, frequency of a minus frequency of b. Now here odd minus even, 1 minus this 2 frequency is -1, and same thing for here, this 1 odd minus even frequency of this 3 is also be, our answer is -1. And both the cases we have to getting -1, then we have to find maximum of both these. Here is max is equal to -1, so here answer is -1. So same thing for here, we have their frequency string and then their k value. And now you have also take care of the digit we have to consist here 0 to only 4. Okay, this is our range of digits, and now let's discuss their example test cases with dry run solution. And so this is our example, and we have to identify a substring of at least k is equal to 4 possible substrings, like this is 1 2 2 3 3, and this is our string. Okay, and now we have there at least 4 length, this 4 length, like greater than is equal to k. And now at least 4 means 1 2 2 3, this is one substring, and you can say this is the 4 length. Okay, and you can say 1 2 2 3 3, and this is a 5 length, and so on. We have to check with all these values. And now our step 2 is we have to find their frequencies of each character and each substring. Like here we have their frequency of 1 is 1, and frequency of 2 is 2, and frequency of 3 is 3. Sorry, 3 is 2, and this is our odd, and this is our even, and this is also be even. And now this is our second step. And now third step, we have to compute the possible values with their frequency of a minus frequency of b, and we have to find values. Like we have to choose a is equal to 1, and this is odd, and we have to use b of b. Let's suppose b is, we have to find 3, let's suppose. Okay, this frequency, and this is even, and so the frequency of a minus frequency of b is the count of this one is 1, and their count is 2, so 1 minus 2 is minus 1. And same thing for frequency of a minus frequency of b, with check with this a is odd, and this b is, sorry, this c, one second, and you can say okay, sorry, so this b with 2. Okay, you can say this 2 is our also be a even, and so the difference of this one is 1 minus 2 is minus 1. So after this we have their maximum difference of let's suppose this one is s1, this one is s2. S1 minus s2 is equal to what we have to get, minus 1 minus 1, then we have answer is minus 1. So here is minus 1. And now let's discuss this example second. The example is we have 1 1 triple 1 1 triple 2 1 1. Okay, and this is our example, and we have to given k is equal to 3, and now this is our string. And now we have to consider the at least the length is equal to greater than is equal to k. Okay, and greater than is equal to 3, you can say. And the substring we have their values is 1 1 2 2 and 1 1 2 2 2, because of you can say also consider this whole values, because this 1 1 1 1, this is even. Okay, and this is odd, but we have to find their substring. Okay, only substring, so that's why we have to take this one 1 1 2 2 2 2. Okay, so then we have to count their character frequencies. So character frequencies are one appear 2 time, and this 2 time is our even value, and this 2 appear 3 time, and this is our odd value. Okay, and after odd value we have to compute the possible values. The possible values are frequency of a minus frequency of b, and then we have to then we have their values of the frequency of a, and then frequency of this odd value, odd minus even value. Okay, and you can also be here, yeah, odd minus even value. So odd value is here 3 and even value is 2. So 3 minus 2 is 1, and now the maximum is equal to 1. Here you can say the maximum is equal to 1. So now let's discuss this example third. This example we have to given 110, this 110, and the k is equal to 3. Okay, and we have their frequencies, and the one frequency is 2 time, and this 0 frequency is 1 time. Okay, and this is odd and this is even, and the frequency of A minus frequency of B, you can say odd minus even, and the odd minus even is 1 minus 2 is equal to minus 1, and this is our maximum. So then we have to return minus 1. And now the brute force solution is of this question is, we have to calculate, like here the brute force solution is, we have the strategy of brute force solution, we have to calculate with sliding window approach. Use a sliding window with minimum size of k, and like this is greater than k, you can say we have to iterate with checking with their possible values and find their substrings, and then we have to examine all possible substrings. Like here only I calculate the possible substring of only this one. You can find another substring, but I only said that this is the possible way. Okay, and after a sliding window we have to count their frequencies counter, like frequency of A comma frequency of B we have to calculate here, and then we have to analysis of odd and even counts. Okay, and the key step we have to follow here, first we have their sliding window with k, and then we have to count their character frequency. Okay, here we have to count their character frequency, and then after character frequency of odd and even, then we have to maximum difference of odd minus even values. Then after all operation we have to process all values, like here only I also discussed here only one substring, but here you can compute with multiple substring and you can check with all maximum values. Okay, so after this we have to repeat this process, then we have to return the values, and this is taking O of n square into k time, so this is not efficient solution. Okay, this is not efficient solution of this is sliding window of O of n time, and frequency is taking O of k time, and the character comparison we have taking O of n time, like O of n into n and into k, so this become O of n square into k. And the performance you can say it is also based on nested for loops, and then we have to checking with window size all time. We have no any pre-computation technique here, so that's why this solution getting a TLE solution. Okay, and you can say once again you can say like we have create a unordered map. Okay, unordered map of frequency, and this frequency we have to calculate only consider the substring with at least length of k. We have to iterate on that line, and then we have to fix the left boundary. Okay, left side we have to fix this is our one substring, and then we have to calculate all the substring, and then we have to check with their odd values, and let's suppose a and 1, we have to calculate the odd values, then we have to calculate the same for B value. Okay, and then this is taking a nested iteration, so that's why this is getting out of bound. Okay, so now let's discuss their optimal solution. So optimal solution is we have to use to count frequencies by Fenwick tree, and this Fenwick tree we have to count their binary index tree. This is called binary index tree, and this binary index tree we have to calculate all these frequencies, and then we have to count their frequencies efficiently. And now here this is our large value. This large value is tracking the negative values and to track minimum difference all values. And here this is our, so here this is our segment tree code, sorry, Fenwick tree code. And this Fenwick tree is define a binary index tree. And here first we have to declare their size, and this size store the tree size, and then this tree is a vector to store the values, and this is store the values. And then we have to calculate with their constructor and with size 0. Here we have to create a constructor with size 0. And then here this Fenwick tree, and this is parameterized constructor, and this parameterized constructor is basically used for a Fenwick tree with size of n+1. This n+1 setting all the values with infinity, and then we have to compute all the values. And then here first we have to initialize with Fenwick tree with given size of n, and then we have to assign all values with infinity. And after this this is our init condition, initialization condition, and then we have to update the values. How we can update the function with the Fenwick tree at the index of I. This is our index of I, and the index of I we have to minimum value which we have to encounter here. And after encountered we have to we have their loop. This is our loop for, okay, we the loop is to propagate the update to all relevant indices, like similar, this is similar for prefix sum. Okay, like here we have to propagate their values. We have their propagate their values and their size, and then we have to find their minimum. And this is a basic approach of prefix sum. And then we have their query, and this function return the minimum value of the range of 1 comma I. This 1 comma I range we have to find their values, and this is uses for prefix minimum approach. This is called prefix minimum approach. And then this is after Fenwick tree initialization, then we have their main function. This main function we have to compute all over the values. And the first we have their n and their size, and this size and their frequency. And first this f of, and this f of I and d. Okay, and you can say the values basically. And this this is the digit up to 5, like you can say 0 1 2 3 4, okay, so on. And we have to calculate the values, and then 0 to 4 we have to set their range. And then we have to build the frequency table, and this is our frequency table of fz. And after frequency table we have to compute all the values with all the pairs. And like here f of I plus 1 of d, it copies the values from, okay, once again this copies the values from their update value and the current character. Okay, and after current character we have to calculate with their answer. And this answer we have their negative values also be initialized, and then we have their taking the large value here. And then we have iterate the loop, and after iteration we have here calculate this like this one. Okay, here after calculation we have what we have to find, x comma y. This is our pairs. After pairs where x not is equal to y. And also we have to calculate their frequencies here, and the frequency of x minus frequency of y. That's why we have to use this solution, this one, this these two loops. Okay, and then here we have their difference of n plus 1, a plus 1 and b plus 1. And this a we have to, you can say this is odd, and this b you can say this is even. Okay, and this also be indicate their frequency of, you can say this a of I, store the frequency of x, okay, frequency of x, and then we have there and 1, and this calculate the odd value, and same for b of I. And here and then here we have there also calculate all the values, and here we have to calculate their difference, okay, the difference of x minus y, you can say. And then we have to then here we have to create a Fenwick tree with different combination of x comma y. The combination is odd, odd even, and odd even. The combination, 4 combination basically we have to calculate here, and then the values are, and then here the best and this position, and the position track the left and of the sliding window, and this j, and this j is on the right end of the sliding window, okay. This is the left and this is the right end. And then we have their while loop, and this while loop we have to maintain the sliding window with removing the old element here, okay, old element, and this is called pre-computation. And then here we have to encounter with this mask. This mask basically for a of position of left shift of 1, and this b of position, okay. And we have to encodes the odd and even, and we have to properties of 2-bit format here, 2-bit format. And this 2-bit format is basically what we have 0, 0 and 0, 1, and third is 1, 0 and 1, 1, and this is for 0, 1, 2 and 3, okay. And we have to calculate here by using mask, okay. And then we have to find their difference after update all the values by using their Fenwick tree, okay. Here we have to call the prefix sum of update, and then we have to find and determine the correct bit mask for the current state of j, here the current state of j. And then this frequency and the Fenwick tree queries, we have to previous difference and find their previous difference, and then we have to find their maximum value of their difference, and then we have to also call their query, and this query we have their values of prefix minimum, and then we have to call the prefix minimum, then we have to find their maximum value, and again we have to find all the maximum values. We have to calculate, like here first we have to find substring, then we have to find their values, and these values we have to find all the possible values, like let's suppose you have getting 1, 2, 3, 4, 5 and so on, and then here we have to store here, and then we have to find maximum of all the values, okay. Then we have to return answer, and here we have to update the answer with the maximum difference found across all the character pairs of x comma y, and then we have to get our answer. So now let's discuss their time and space complexity. And the time complexity of this code is, we have also be O of 5 into 5 for the loop, okay, the 5 of 5, and into n log n is equal to O of n log n. The time complexity of this code is O of n log n. So basically this n log n is coming from we have to build the frequency, and the build frequency array is O of n time, and iterating all over the pairs of x comma y, it is taking O of 25 times, because of O 5 into 5 is equal to 25, so that's why O of 25 times. And then we have there processing the substring with Fenwick tree, and the Fenwick tree is taking O of n log n time, and the total time complexity of this code is O of n log n, okay. Here also we have to discuss it. And now the space complexity of this code is, the Fenwick tree is stored O of n time, and the frequency, and we have to also declare their arrays of O of n time. So the total space complexity of this code is O of n time. So now the final thoughts are like, the Fenwick tree and the binary index tree is efficient for query the smallest difference in the given range, and the range we have to given 1 to I. And also the sliding window approach is to valid for the process the valid substring, and then we have to bit mask of A of I and B of I, and this and allows the efficient track the odd and even count. Okay, and then finally we have to optimize the solution by handle the substring and their length of k and their computations. And one thing is our first, and you can say here once again, this is our first test case for 1 2 2 3 3. Okay, you can say 1 2 2 3 3. Okay, so this is our first example, and k is 4. And then we have how to store and how to build the prefix frequency of this test case. And like we have their Fenwick tree, okay, and how we calculate the frequency of I of D, and this D is our digit. Okay, digit, and this is I is our index value. And now we have to calculate all over the index, like I is equal to 0, I is equal to 1, I is equal to 2, up to 4 times, and the frequency of 1 is our 0 1 0 0 0, and 1 appears 1 time. Okay, and the same thing for here, frequency of 2 is our this 2 is 1 0 1 1 0 0, and here the value here 2 appears here 2 appears 1 time, and the frequency of 2 again, the frequency of 2. Okay, here 0 1, the count we have to increase, count plus plus, then the value is 2 0 0, the here the count is 2. And if efficiently we have to track all the values by using Fenwick tree, and we have to build their prefix frequency array. And after frequency array we have to calculate their character pairs of x comma y, and this x comma y is our digits of x not is equal to y, and we have to find their difference of difference of I is equal to frequency of x minus frequency of y, and then we have to find their possible values by using Fenwick tree. And I hope you understand how actually we have to work with their Fenwick tree approach, and also we have to discuss their segment tree solution for their brute force solution. And so thank you everyone.